I just want to take some time today and look at some things about trig identities. I know students always struggle with this, and so let's just kind of get into it here. First of all, some big tips. Change everything to sine and cosine. That's a really good tactic. You don't have to do that, but it can be very helpful. Also look for sine squared and cosine squared. You know those functions, so sine squared plus cosine squared equals 1, and then therefore 1 minus sine squared equals cosine squared, vice versa, etc. So look for those and replace those. And otherwise, the big thing is you don't use both sides of an identity. So if you're trying to prove something, you have to take one side, manipulate it, and get the other to show that equality. Alright? You can't take one side, get it halfway, take the other side, get it halfway, and say, oh, now they match. Because then you're starting with the assumption they were equal, but they're not. And you don't know that. And so you need to prove that. So you can't use both sides because you don't know they're equal. That's what you're trying to show. Alright? So let's just kind of see this in action. Also, I'm going to attempt to try to work out some identities in different ways. And so let's give it a shot here. So here's an identity, and right away I can see they're all sines and cosines, so that's really good. I think I'm going to distribute this out. We could say the nasty word FOIL. I don't like saying FOIL. I like saying distribute. So if I take sine times sine, that is sine squared. Sine times cosine. Let's see here. That's a plus sine theta cosine theta. And then if I multiply this one through, that's negative cosine times sine, or negative sine theta cosine theta. Ooh, that's nice. And then I get a minus cosine squared theta. So I can see those cancel. So that's good. Again, I'm not touching the right side. Only use one side. And so I get sine squared minus cosine squared. And I know I need to end up with some cosine squared stuff, so that motivates me to go, hey, can I change that into cosine somehow? And of course I can. So sine squared theta is equal to 1 minus cosine squared theta. And there you go, I got it. And now there's two of them, and 1 minus 2 cosine squared theta, and that is equal to my right side. So there you go, identity proven. Alright, so that was one method. Okay, probably the easiest in my mind. I don't know, maybe not. Also, I think I said back here, well, I didn't say it, but the bullet is there. So usually you start with the more complicated side, because it gives you more to work with. And so I started on the left and used the left because it's more complicated looking, and so it just felt like easier to handle. Alright, let's try to do this another way. Maybe I decide to work with the right. Oof. I mean, I could change the cosine to sine, so 1 minus sine squared. It's probably not going to be the most helpful. Why do I say that? Well, the left is a mixture of sines and cosines. So if I change cosine squared into 1 minus sine squared, well then I no longer have a cosine. I need both things. So I think if I was to use the right hand side, I would change 1 into sine squared plus, cosine squared theta, and then we'll have a minus 2 cosine squared theta. So cosine squared, a minus 2 cosine squared, so now that is sine squared theta minus, whoops, not 2, just minus one of them. Plus 1 minus 2, that's a minus 1. All right. Now, this is where, it gets hard, and you got to pull some tricks out of your bag. Not any great trig identities or substitutions here. Yeah, no, not anything great. So I think what I would do is just have to kind of almost be lucky. If you have a squared minus b squared, hopefully maybe you remember, but if not, that's equal to a minus b times a plus b. That's a common factoring thing that comes up a lot, and so it's a good thing to remember. And so in this case, my a and b are my sine and cosine. And so if I have sine squared minus cosine squared, just using factoring rules, we know that that is equal to, see here, sine theta minus cosine theta, and then sine theta plus cosine theta. And hey, lo and behold, that's exactly the left-hand side, and I got it. Which, by the way, on the last slide, you might be like, hey, well, why didn't you realize this was this, and then just change it right away into that or something? Well, I could have, but I just didn't see it. It's easier to see this and then change it into factored form than go backwards. So there you go. There's a second way to solve that identity. So I started with the right and got it to look like the left. All right. Let's see. Can I come up with a third way to do this? Using the left side or the right side? Oh boy, I don't know. Those just seem like the most obvious kind of ways to dig in there. Yeah, I mean, I'm not really seeing a third way. I took the two cleanest, obvious ways. I mean, really, if you're working on the right-hand side, distributing that out is kind of your only way to really dive into it. I mean, the only other thing I could think of is, like I said, we could have done this. Change that cosine squared into 1 minus sine squared. It doesn't really do much, and in fact, it almost complicates things more and not really helpful. So, yeah, I'm not convinced that that's really a great idea, but I mean, we could run with it. 1, and so that's minus, so minus 2 times 1 is minus 2. Minus 2 times that is a minus 2 sine squared theta. And so 1 minus 2 is a minus 1. And now we're starting to go circular. I mean, because this looks an awful lot like kind of what we started with, and so it's not really getting us there. So that's a great example of like you try an idea and you realize, oh, this is kind of getting me in a loop or getting me nowhere, and so no, not good. So yeah, so I think we did it kind of the two obvious ways. We used the left-hand side, we used the right-hand side. I think we're good, making a lot of sense. All right, let's look at one more trig identity and kind of round things off here. So here, this one has a mixture of secants and sines and all that. Notice the variable is x instead of theta. It's a variable. It doesn't matter. Traditionally, we use theta. but it really doesn't matter. Now, I could start with 1, but I mean, there's so many options. What do I do with 1? What do I change it to? I mean, that's just really hard to work with. So many endless options. So this is a great example where, yeah, you definitely want to just start with the left and try to simplify it down. Again, one tip, change everything into sines and cosines. Don't have to. There are some identities out there with secant and stuff. So like secant squared is 1 plus tangent squared, I think. So I could change that secant squared into that. But I'm just going to go, and like I said, I'm going to just change it all to sines and cosines. So 2 times, now secant squared is what? That's the same as the inverse of cosine. So that could be rewritten as 1 over cosine squared. And we got an x here, not a theta. Sine squared x, I'll leave that. And again, secant squared over here is 1 over cosine squared. Okay? All right. So, oof. Oh, I do see something here. So I do have a common denominator. So that's helpful. So I could combine these into one function. So all of it is over cosine squared x. That's the common denominator. And up top, I'm going to have 2 minus sine squared x. All right. Interesting. I have not worked these out ahead of time, so I'm just kind of flying blind here, trying to give you the authentic experience. So 2 minus sine squared, so let's see here. Sine squared I could turn into 1 minus cosine squared. Yeah. I don't know. Is that going to do it? I guess I shouldn't resist. I should just start diving in there and trying. So some of you are probably sitting there screaming. You're like, no, do this, can't you see? Right? And sometimes you can't. And that's just the thing, is you just get kind of stuck or something, and you're not seeing it. So I feel like I made an error somewhere. Like, as in, this isn't true. Something fishy here. Ah, I did make an error. That's why my brain is blowing up. I'm going to copy my problem. That 2 shouldn't be there. Alright, sorry. Alright, now my brain's better. Oh, this is so much nicer. Done. Alright, there we go. So that was a clerical error on my part. So yeah, what's 1 minus sine squared? That's cosine squared. That's better. I knew that 2 looked fishy, and but now I see where I got it from. Oh, hey, look at that. That's 1. Done. So we got that. So took the left side, manipulated it, got it to the right side. By the way, now that I have the correct thing there, let's real quick solve it another way. Now that the 2 is out of there, well, both of those have a secant. I could pull out the secant, and then that would give me 1 minus sine squared. Well, what's 1 minus sine squared? That's cosine squared. Well, secant and cosine, they're inverses, so secant times cosine, 1. Right, well, and there's the squares, but that doesn't matter. Or to put a finer point on it, if you're still not buying it, well, secant is 1 over cosine squared. Secant squared is 1 over cosine squared. And so they cancel, and there's your 1. So that's another way we could have done it. So there you go. All right, friends. Well, I hope that helped with identities. I hope that gave you some good advice. Maybe helped you kind of see how to tackle those. But again, you got to start with one side, work and get to the other. Okay. Don't play with both sides. All right. Otherwise, there you go.